When we finally hit the West Coast with this strategy and there wasn't anywhere else to go, the extractive strategy created deserts and dust bowls. To bring them back into production, we then mined fossil solids, liquids, and gases from other faraway regions, coal, oil, and gas, and dumped them on the ruined dirt to breathe a little more life into it. The dirt, of course, contained none of the rich biodiversity that acts as checks and balances in a healthy ecosystem, and so more fossil fuel-derived pesticides and herbicides had to be added to maintain some productivity until the soil was not only exhausted, but toxic as well. As Professor Hecht declared in class one day, "We don't have farms anymore. They're merely open-air factories." That is the consequence of an extractive economy that depends on mining the earth. But there is one form of extraction from the earth, along the meridians, along the lines of longitude, that is almost universally good. In our drawdown textbook showing the 100 best solutions and their impact by 2050, it is ranked solution number 18, reducing 16.6 gigatons of CO2 at a net cost of $155.5 billion with a net savings of $1.02 trillion. And that drawdown solution is the extraction of heat from the earth, something we have far too much of right now, and it's called geothermal power. And between improved technologies for getting energy from the delta T of temperature differential between hot and cold areas and improved turbines, it is turning out that we can use various types of geothermal gradients down in the earth and right at the surface for a wide variety of things, including highly efficient HVAC systems, to say nothing of electricity generation. There are updated figures for alternate modeling scenarios on the Drawdown website. As a graduate student, I traveled to Iceland to see this climate-friendly miracle in action and regaled with other urban planners in the geothermal electricity plant's wastewater, sitting with a waterproof copy of McDonough's Cradle to Cradle in the Blue Lagoon Spa at 3 a.m. in the perpetual twilight, asking them why this solution wasn't used everywhere. Later that year, I went up the west coast of the United States to Geyser, California, to videotape Old Faithful spout up its perpetual fountain of clean energy, and then to one of our own domestic geothermal power plants. I made an informational video of it that you can see in our resources section. And that is where I learned that the entire west coast of the US, to say nothing of the Rift Valley up and down through Africa southward, and the Middle East and Italy northward, and the entire archipelago of Indonesia and Malaysia, on up through Japan, to say nothing of Hawaii, are hotbeds of geothermal heat that can be used to generate carbon-neutral electricity with none of the risks of the nuclear power plants like Fukushima that have made such a mess. Everywhere where the plates that make up continents meet, they create what is called the Ring of Fire, a ring of fire, and it spans the globe. You can see it active wherever you find volcanoes, but everywhere else it manifests as hot springs that can be harnessed for clean steam to drive turbines. Unless you think you must drill deeply to get it or find places with extreme temperatures to make it useful, in 2010, National Geographic sent me up to a resort called Chena Hot Springs north of Fairbanks, Alaska, where the owner, charismatic Bernie Carl, showed me his Rankine cycle gas turbine that uses low-grade thermal energy, the mere temperature of the hot spring spa itself, to create electricity. It doesn't need high-pressure steam because it uses organic solvents that have a lower heat of vaporization.